happy to be here with you, and I want to talk about persisting relations across time and space, about how we can persist objects and the relations between them in our Ruby applications or Ruby systems. So a quick introduction. My name is Piotr Szotkowski, and if you think that's hard to pronounce, I also have a nickname that I have no clue how to pronounce because I ever saw it in print. And I'm an alumnus of Mendicant University. This is where I shaped up my Ruby skills, and thank you. Apparently most of you know what Mendicant University is. It's a wonderful endeavor created by Gregory Brown and now staffed with quite a few more people who are somewhere there. And I will go back to the nearest Mendicant University activities at the end of the talk. And I'm also a Ruby developer. I work at a new company in Warsaw, Poland. We're so fresh we don't have a logo yet, so I shamelessly stolen this one from the Git community book. We're called Rebased. And I'm also an assistant professor at Warsaw University of Technology. I work at the Institute of Telecommunications, and this is where I try to sneak Ruby into the old world of 20th century academia, basically. And that's where I learned Ruby when working on my PhD, and when I decided that it's a very nice language, and there's a lot of paradigms that you can use in Ruby that are very well used to be, they are very convenient to use in the academic world. So what this talk is going to be about, well, you can try asking yourself, what could I mean by persisting relations, time, space? What can I possibly mean by all those things? So persistence is what we need for our Ruby objects, because whether we have a web application that people come back to and hit with separate requests, or whether it's a command line utility for doing some stuff, we almost always need to persist some of the objects that we have. And relations are the tricky thing to model because they are usually heavily tied to the persistence, whether it's a database or some other sort of persistence that we use. The way we model relations are very heavily tied to this. And by spaces, I mean different ways of persistence, but eventually what we want for our Ruby objects is basically time travel, and unfortunately we only know how to make them travel in time and forward, but maybe eventually we'll also be able to do the reverse, and we can somewhat cheat on that by versioning. So where do we persist? What do you use for persistence? Database. Very good. So what do we know about databases? A database is a black hole into which you put your data. If you're lucky, you'll get it back again. If you're very lucky, you'll get it back in a form you can use. That's one problem with databases. They are not the Ruby systems we like to play with. They are not the Ruby systems we live and breathe. They are that other thing that we communicate with. And the other thing is that very often it's hard to model things right. I should like to find a person who decided that since bookmarks and history were both lists of URLs, they ought to be integrated into a single database. I should like to shake him warmly by the throat until his head comes off. This is a quote from Roger Burton West about how Firefox stores the bookmarks and history. And if you don't know the Haste software mailing list, I highly recommend it. This is the perfect place to be in and to take part of if you're a software developer. So where do we persist? What do we use for the database? Like the most obvious choice. Okay, there's still hope. But usually the answer is MySQL. And what do we know about MySQL? That's the first half of the quote from Will Jessup. The second half is much less fortunate for MySQL, so I left it out. But this is another thing that I very strongly relate to about MySQL, because I started my work as a localization engineer. Yeah, but really, all the differences between relational databases, they are somewhat disputable. MySQL does have wonderful engines. You can have in-memory storage. You can have one of the backends that does not respect foreign keys, which is wonderful because it can be faster. Although if you don't know that it doesn't respect the foreign keys, it's kind of not that good. But you know, there are other relational databases. So like MySQL, PostgreSQL, SQLite, which we learned to use for our testing because it's so much faster. There's actually an embedded version of SQLite, so you don't even have to have SQLite on your system. There is a, so those sites will be, or actually are online, so all the links will be clickable. But there is an embedded SQLite that you can use in a pure Ruby system. And basically, when we want to persist Ruby objects, we serialize the properties to database types. So we need to figure out how to represent them. Strings, numbers, integers, floats are easy. It comes a bit harder when you have geographic locations. But there are relational databases like PostgreSQL, which does have geometric types. It has points. You can say, find me all the contacts that are in the vicinity of this given point. And if you store the points as a point type rather than floats, for example, PostgreSQL can do the work for you. There are array types in PostgreSQL. If you have posts in your weblog, which is, I think, the generic example, and you tag them, you don't necessarily need to have in PostgreSQL a separate join table for joining posts and tags. You can have a tags column. It can store arrays of tags, and you can ask PostgreSQL, please give me all the posts tagged Ruby and persistence, or all the posts tagged Ruby or Smalltalk. You can do that only having by tags column and having Postgres arrays in it. There are a lot of things in PostgreSQL types. You can have your own types in PostgreSQL. It's very worth learning what you can do with PostgreSQL. But basically, we model our classes as tables. We model our objects as rows in those tables, and the properties as columns. So basically, this is not always the ideal solution. So the world came up with the very broad term of NoSQL, which doesn't mean anything really, but one of my favorite quotes about databases is that database research has produced a number of good results, but the relational database is not one of them. Of course, it's tongue-in-cheek, and it's very, I don't know, more funny than probably very true, but this is something that people came up with once they learned about all the downsides of relational databases. And I absolutely love this opinion about porting SQL language to NoSQL databases. This is not necessarily the best thing to do. So, but NoSQL is a very broad term, and if we try to narrow it first to document databases, like CouchDB or MongoDB, and again, there's an embedded version of MongoDB. If you didn't know this, this is a very interesting idea. You can have a pure Ruby MongoDB without having the actual server for testing. For example, if you want to have a production-like system for testing without setting up the MongoDB server. And we basically, again, we serialize properties to database types. We can have arrays, which are somewhat better supported. We can have hashes, especially in MongoDB. I think CouchDB does the same, which is very convenient. We can have nested documents in, I think, most of the document databases. So there are a bit better ways to persist objects. But still, we say that our classes are collections, our objects are documents in these collections, and the properties are basically fields in those documents. The good thing is that more often than not, we can go with a schemaless approaches, which can be very useful quite often. How do we persist elsewhere? Well, in memory, if we use Redis, which is in the general opinion an in-memory kind of database, but you can actually have for example, and that's actually in production in Poland in one of the bigger companies, you can have another Redis server that is synchronized with the first one, and that Redis server stores everything to disk. So you don't get the overhead of persisting Redis data on your main production system, but still have persisted Redis. And if you work with Redis a lot, there's a Redis object collection, I think, which is a very nice way of doing the opposite. What we try to do is basically there are classes that represent Redis types. So if you can contain your Ruby objects to be types of those, to be objects of the Redis object collection classes, you have a one-to-one mapping to Redis, which is very convenient. There are graph databases, which are really nifty for doing any kind of social graph activities, any kind of basically storing relations, and I'll get back to this. There are directory services. For example, if you have, imaginary example, you have a university department that has all the students and staff in LDAP already for authorization and authentication purposes. Then you can use that as your persistence backend, and you can model the rest of your system in LDAP as well. But there are actually other things that are very underrated and can be used especially in your pet projects. YAML record is a active record-like library that lets you store things in objects in plain YAML files, which is kind of very useful, especially if you do a lot of hectic development and you really need to look at the data very quickly. And pstore. Pstore is persistent store and is, I think, my favorite standard Ruby library that is really underrated. It's in the standard library. You already have pstore in your systems wherever you have Ruby. It has two backends. It can either marshal the objects or put them in a YAML files, and all you need to do is either require pstore or require YAML store, and then create a store object with the name of the file. And if you thought about a very hypothetical example of somebody who, for some reason, likes to collect quotes and maybe wants to have a command line utility that would paste those quotes at the end of the emails. I'm really going very crazy at this moment, but just think about it. And maybe that person, had some free time at his honeymoon and created that application. And you could do something like this just by using the code on this slide. You basically create a quotes tract, which is an author and a text fields. You open a read-write transaction to the pstore object, and then you access it like a hash. So we want to store two quotes on databases, so we create a key, DB key, if it's not there, and we put the two quotes. And at the moment we close this block, this is atomically committed to the file. So it's a very simple but very powerful. Obviously, you have to have write access to the file system, which nowadays is somewhat less popular than it used to be. But this is actually very easy. And if you want to read from the pstore store, you can have read-only transactions, which can be concurrent. They only open the file for reading, which is fast. And if we wanted to print the two quotes that we put in, we would just do something like this. We would access the store just like a hash with a DB key. And for each quote, we would print out the text, the two dashes, and the author, and an empty line. And if we wanted to run this, we would print out the two quotes that we stored just a second before. And if we try to look at the database, it's just a YAML file. So it's very easy if, for example, you spot typos in your quote. That imaginary person, if they spotted the typos in the quotes, then they could just edit the file rather than trying to figure out how to add editing ability to his solution. So basically, pstore is this very old but very useful, very underrated solution for persisting your objects. You probably should try to use it in your next project. So the problem with relations. The problem with relations and persisting them is that it's usually very strongly tied to the way you persist things. If we have a kind of set of objects, we have two parental units at the top. We have a kid at the bottom. The kid learns geography and writing. One of the parental units works at Wall Street. The other parental unit stays at home and does interesting things with the toys he has at home, and he also goes to conferences to watch bizarre slides. Well, that's how this could be when it comes to relations. You have the parental relations, you have the Wall Street mom, the stay-at-home executive, he goes to the conferences. The problem is that all those relations are usually the gist of your system. More often than not, they are at least a very important part. And the way that you model them is also really important. Some of them have additional fields like the date of disposal relationship started, the role at which the person participates at the conference, and so on. So how do we do that in a relational database? You would think a relational database really is all about relations, but it's not really. It's about so the name relational in the relational database is about the relations between rows. And it says that rows in a single table should have about the same things in the same columns, and not really about relations between rows in different tables, which is what we talk about here. If we have one-to-many relations, we use foreign keys. If we have many-to-many relations, we use a very different way of joining this by using join tables. And dereferencing of the relations, if we want to find the parents of the kid, we need to join queries through using either the join tables or at least the foreign keys if these are one-to-many relations. So in document databases, it's quite different. we can use either embedded documents. The canonical example is if you have a post and you have comments, they are so tightly related to the post. You very seldom want the comments without the post, that you can embed the comments in the post and then get the post with the comments as a single object from the database. And otherwise, you use document identifier references. You basically say, well, the author of this post is in the people collections under ID 74. And in MongoDB, you actually have implicit dbrefs if you create a hash that has $ref key with the name of a collection and $ID key with the object ID. This can be dereferenced either by your driver. You can basically say, this is the way foreign keys, in a way, are stored, and you can dereference it very easily. But it's always costly. We usually do this on the client side. If we want to do it on the server side, we need to write functions that do that. And there's actually a Mongo hydrator, which is somewhat different way to approach this, but you might want to take a look at this if you haven't heard about this. But the referencing, either you do it client side, which means subsequent hits to the database, or you do it server side and you need to kind of program it to do the dereferencing rather than having a simple join statements that are well known. How are we modeling relations elsewhere? In key value stores, I think there isn't a very standard way. It very depends on how you model your objects and your properties there, so you have to explicitly figure out how to model them. In graph databases, this is really cool. In graph databases, the whole point of graph databases is relations. You have vertices that show the objects, and I'll show you this in a second, and the relations are basically the edges on the graph. And if the graph has freely labeled edges and vertices, you can store all the data about the relation on the edge, all the data about the objects in the nodes, and this is in the vertices, and this is very convenient. And you can do all kinds of graph traversal things. You can do all kinds of proximity metrics if you want to find all the people in that other social network that I have 3 shakes of hands to. Then the graph database is a really good way to store it. And there's a picture about graph databases that I shamelessly stolen from Wikipedia, which basically shows you that you have those vertices with people and one with a group, and membership relationships and friendship, let's say, relationships or knowing between the 2 people are modeled as edges. And this is very similar to what I showed you before. So graph databases are really very, again, I think still underrated ways to store things, and I'm pretty sure they are already quite big at all the social applications and will be even more big as the times come. But what if we modeled relations just like objects, like all the other objects in our system? We would then have a relations table or collection, and if we had a schemaless database, that could be very flexible. We could have all the relations in our system in one big table or in one big collection. And the drawback is that the referencing would be 2-step. You basically would have to say, I want this object. I then need to fetch all of its relations, and then all the other ends of those relations. But the flip side, you have a lot of easily aggregable data. You have all this one huge collection of relations that you can mine for whatever kinds of relations there are in your system. So it has good sides and bad sides, obviously, but I think it's an interesting idea. So basically, you would have all this, a collection of, let's say, people, a collection of hobbies, of conferences, of workplaces, things you study, and then this humongous collection of relations between them. And just a quick tangent here. When you create a table that is named users, if they are really users of your system, that's probably right, but maybe, you know, naming can be a bit more improved on. And the other quote I really like is calling the table people, not users, a small blow in support of humanity. This is a bit like the recent opinions about human resources calling humans resources, obviously. And the other thing that I really would love you to all to read, there is a great article, Personal Names Around the World, on the W3C.org website. And if you create in your next system a people table that has first name and last name, please, please, please have a very good reason, because first name and last name is probably the worst thing you can do if you want to track people's names in anything else than a Western Anglo-Saxon reality, because even in Hungary, they actually flip the first name and the last name. And, in Iceland, in Iceland, they have a very different meanings for the first name and last name. Do read this. It's a very well worth reading piece. So again, if we had relations as objects, what we could do is model everything the same. So we could, if we had a very good abstraction of how we persist things, then we could actually change the persistence layers very easily, because as soon as we don't have relations as foreign keys, it's very easy to switch a relational database. Well, very easy from academic, totally, detached from the reality point of view. But in theory, very easy to switch your backend systems, and basically everything is the same. Everything is an object that you can track one way or the other and persist it. So the last big thing that I want to talk about is obviously a set of Smalltalk quotes. 95% of what I know about Smalltalk comes from the quotes of that guy. So my favorite is object-oriented programming to me means only messaging, local retention, and protection and hiding of state process, and extreme light binding of all things. It can be done in Smalltalk and Lisp. There are possibly other systems in which this is possible, but I'm not aware of them. So from Alan Kay, which you all probably know who is, but the answer to this quote, and I'm not sure whether it was a conscious answer or not, is that I always thought Smalltalk would be Java. I just didn't know it would be called Ruby when it did, from Kent Beck, which is, I think, my favorite quote about Ruby in general. But two other quotes are that Ruby is like Smalltalk and Perl had a child. With the answer, I like to say that Ruby is the love child of Smalltalk and Lisp, raised by Perl, the eccentric nanny, which, if you know Ruby well enough and if you know other languages, is very, very true and to the point. And the last thing that we all, I think about Smalltalk programmers, that they are very kind of high on the abstraction. So Smalltalk programmers do not type, they lean their heads towards the monitors and meditate. The more advanced programmers do not even need monitors, and this is something that I think we in the Ruby community like to think of ourselves, that we have all those short methods, 6-line methods, and all those beautiful systems, and all those cloud services that we can use. And so Smalltalk and Ruby, I think, are very similar in a way that makes it's a big benefit for Ruby. So why am I bringing Smalltalk in persistence talk? Well, basically because Smalltalk had this wonderful thing of GEMSTONE, which is an object database for Smalltalk, and it's a way to persist objects and share them between processes that is totally transparent from the point of view of your system. You basically have objects and they're there without any explicit saves, reads, and so on. And it's also the company behind maglev, and maglev is a Ruby implementation with integrated object persistence. So what they're trying to do is bring GEMSTONE to Ruby. It will be a proprietary system, which is not necessarily making me very happy, but at least when they're finished, which hopefully they will eventually, it's a way for us to have object persistence. In October. All right, yeah. So, perfect. There will be an October when they will release this, so hopefully soon enough. So now that people are considering NoSQL, will more people consider no database? It's a recent quote from Martin Fowler. So what about Ruby object databases? And this is the kind of part when I'm really happy that in October we will have a object persistence. There were other solutions. Madeleine, which to the best of my knowledge died in 2006. ODB, same. HybridDB, which actually models objects as a way, somewhat like hashes, which is a very JavaScript-like way of modeling objects, and they persisted the hashes in a very universal way that would be independent of whether it's a relational database, a document database, and so on. So HybridDB, I hope it will be revived, but so far it looks like it won't be. Cubehole, I think this is how it's pronounced. It's a marshalling on SDBM. SDBM is a very typical Unix tool for persisting things and simple database management system. So Cubehole does this by marshalling objects and putting that in SDBM. Worth checking out. And the last one is Ruby Object Database, ROD, which is not there yet. It's heavily developed by a Polish developer who does a lot of text analysis, and he has humongous text corpora that he can't pull into the memory all at once. So he figured out creating his own object database is the way to go. he hopes to have something that is production ready near the end of the year. So this is something also worth checking out. But basically the problem is, I think object databases will be somewhere there in the future for us, are not there yet. I really do hope they will be there because they would be really, really useful. So the last thing I want to, the really last thing I want to talk about is how do we actually persist things. We have this Ruby system and we have those Ruby objects in it. And then we have the database and then we have usually the ORM somewhere in between it. And we use Active Record or Data Mapper or Mongoid or MongoMapper. We have this wonderful new library of RL, which lets us pretend we're not doing SQL, even though if you look at RL queries, it's very obvious that they are not, select where this and that. They are much more, we're still not there yet when it comes to transparent work on Ruby objects. So what I would like to briefly show you is Candy and Ambition, which are two unfortunately dead libraries that maybe are worth reviving, which are something that actually sparked the idea for this talk and something that I really highly relate to. So Candy, created by Steve Alley, who is known for his science fiction podcasts and also his Ruby work, he created a way to persist objects in MongoDB that is totally transparent from the point of view of the system. If we require the Candy gem and we created a conference class that includes Candy piece, the naming is somewhat disputable, but this is how, well, it's his choice. So instead of inheriting, we're including, which is, in my opinion, a very good thing to do. And the moment we did this is the moment we have completely transparent persistence for our Ruby objects. Because the moment we create a new conference object, the Candy behind it connects to localhost by default. So obviously, you can configure it, but really, running all these 1, 2, 3, 4, 5 lines connects to the default MongoDB location, connects or creates a database that is named after your user, or Candy if it cannot find your user, then saves a new empty document to the conference collection, which creates the conference collection if it's not there. So really, all this, as I said, 5 lines is all that is needed to persist your first object in MongoDB. All you need to have is a MongoDB running on a default port, no configuration whatsoever. And the other thing that lies very close to the border of insanity and genius, in my opinion, is the way that Candy handles the persistence. Because Candy has a very small but very powerful method missing, a solution that anytime you call a getter or a setter that is not explicitly defined in your class, like let's say location equals, this makes a behind-the-scenes save to your database that sets the location key to the New Orleans string. And Steve, the last time I checked, which was a year ago, and unfortunately there was no development on Candy since then, actually creates a layer that would do this asynchronously. Because obviously the obvious drawback is anytime you write something to your object, there's a database query. But you can actually abstract it into a synchronous layer. So another thing is that if you save a hash, it basically saves the hash into MongoDB, but you can actually read it right back with events, parties, Thursday. I do hope you all know there's a party tonight. And it has really the, I think, best website that I ever saw for a party. So what Candy shows us, and this is a very small example, there's much more to Candy, is that there can be a way to do object persistence that is totally transparent, because we basically created a new object, set some properties, and the moment we read anything, there's a database select going to there's a select query, or in this case, I don't know. I think that MongoDB calls them selects as well. But there's a query going to the database, and actually the objects are cached as well, so there's a lot of overhead is taken care of, and a lot of other things are tweakable. But this is, I think, a very interesting idea worth pursuing, even if it's not for anything production. But although he does use this into production systems, to the best of my knowledge. And the other thing is Ambition. Ambition is a framework that, again, is dead for quite a couple of years now. But it used to abstract querying your persistence or basically databases, in a way that is very Ruby-like. If you use the active record adapter of Ambition and you had a person class, you basically could say person select and then have a typical Ruby block that would access the person's properties, and behind the scenes Ambition would turn this into this query. And again, it was quite a couple of years ago, so you know, we all have RL now, but again, this is an interesting way of doing pure Ruby things with an object collection and all the persistence being taken care of. And to let you show how, in my opinion, powerful it is, if you switch the active record with active LDAP, the whole Ruby part, the whole select part can stay the same, but the query is very different. This is how you query LDAP systems to get the same thing, which means objects that are valid to have fun with in the after parties, probably. So Ambition, again, hopefully it will be revived because it's a very nifty. If you think of all the backends that you could use, you could have a, I don't know, Flaker backend, GitHub backend, anything that basically lets you stay in the Ruby world while the persistence or data layer being abstracted away. The problem is, of course, these are not really production ready, but I do think that they are worth pursuing. They might not be there yet. There might be look nice, but not really work 15 minutes into when you try to implement them. But there are some things that we should probably all think about, whether we can make our Ruby systems a bit less aware of the persistence behind them. So the main point that I wanted to show you is that we really should consider disassociating the models from the databases. And Steve Klabnik recently said we need something better. Persistence and logic are two separate responsibilities that every Rails app combines. In typical Rails app, you have models, and they are one-to-one tied to the database. And another quote, when I open up a Rails project and the models there is full of 100% active record classes, I shudder. Model does not equal persistence. And this is something that we should really think about, because if we can disassociate the models from the database, it can potentially have a lot of benefits and be so much more flexible, not to mention easier testable. And the thing that you should, if anything in this talk really sparked your interest, you should really listen to Object-Oriented Programming in Rails with Jim Weirich. This is a Ruby Rogue podcast, I think 2 podcasts ago, which covers a lot of how better to model your models, basically, the objects in your system, in a way that is not necessarily tied to the persistence, and how to better program in an object-oriented way, thusly. So just to recap what I wanted to tell you today, there are various ways to persist objects, and if you really have a small project, side project, maybe trying out pstore, which I really like, might be a good choice. If you think how you model your relations, then maybe you can have a very interesting solution in the end that would, if you treat your relations as objects, might be very worthwhile. If you treat them as relations, maybe you should learn about graph databases and how to query them and all the possibilities they give you. Learn about the persistence features, about your persistence features, and think outside the ORM box. Again, just to reiterate, PostgreSQL has wonderful types that people heavily underuse, in my opinion, and try to model things, everything as integers and strings, which is not necessarily the good thing. And please do read the personal names around the world before you create your next people table, if it's called people in the first place. So first and foremost, please do enjoy being engineers. This is what we love the most. This is what we love playing with. Do look at Candy, do look at Ambition. Try to come up with all solutions like this. And if you have any questions, I'm happy to answer it, and you can find me there on the net.